Hello! In this video, we're going to prove the following theorem. Suppose A, B, and C are real numbers. If A is greater than B and C is less than 0, then CA is less than CB. Now in this series, we're using a list of 10 axioms for the real number system, and I'll leave that list of axioms in the description below. Now in this video, we aren't going to need to refer to any of the axioms directly, but we are going to be using some preliminary results which we have proven. Our first preliminary result is, given real numbers a and b, we have the negative a times b is equal to a times the negative b, which is equal to the negative of a times b. Our second preliminary result is, given real numbers a, b, and c, if a is greater than b and c is greater than 0, then ca is greater than cb. So this one's really similar to the result that we're proving. Our third preliminary result is, suppose x is a real number, then negative x is greater than 0 if and only if x is less than 0. And our fourth preliminary result is, given real numbers a and b, then negative a is greater than negative b if and only if a is less than b. Okay, so now let's get into proving this theorem. Now we're trying to prove if a is greater than b and c is less than 0, then ca is less than cb. And to prove that, suppose a is greater than b and c is less than 0. Now, by star, since c is less than 0, we can conclude that negative c is greater than 0. So now we have a is greater than b and negative c is greater than 0. So now let's apply star. In doing so, we're going to take a to be a, b to be b, and c to be negative c. Well, in that case, we know a is greater than b. We also know negative c is greater than 0. So then by star, we can conclude that negative c times a is greater than negative c times b. But then, applying star, we have that these guys are equal and these guys are equal. So then, because this inequality is true, we can replace this guy with this guy, and this guy with this guy. And now, applying star. Since the negative of CA is greater than the negative of CB, well, that means we have CA is less than CB. And that is exactly what we wanted to show. So we have shown if A is greater than B and C is less than 0, then CA is less than CB. So we have proven exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.